Okay, now good day, ladies and gentlemen. Welcome to our second video, or video 2.2 or 2.1, whichever order you're gonna watch these videos on risk measures. So right now we are going to explore one of the most important risk measures that you will find. And normally they use a normal distribution, right? So I have already told you that value at risk is basically it generalizes the likelihood of underperforming by providing a statistical measure of a downside risk, right? So it is that value of X alpha that you are reasonably sure you would not exceed. And I have shown it in this example, right? Again, in this equation here. So var is the value, negative t. We use negative, right? We multiply that var value by negative because we expect it to be in the losses. So basically, when you find your var, it will be as a positive value. So because it explains losses. Again, but then you don't want to write your answer as negative something. So you're going to multiply that negative number, which is your loss, by negative, making it positive. So when you answer your question, you would say, we are 95% confident, or we have this certain level of confidence level that our losses would not exceed this amount of money. That is how you explain value at risk, right? When you are answering the question, right? Your question is not complete without adding that statement, as a matter of fact. You should get a mark for just adding that. So, and then for discrete as well, you can see that it is the value, it is the maximum value of t such that you have your excess, where your excess would not exceed this certain significant value, or its probability would not exceed this certain value. And I will try to show you a few things. Consider X as a normal distribution, right? You are trying to find what your value at risk is, right? So when you consider what your X is, so you are going to find this thing at a alpha significant level. So this would be your equation, right? So this is the equation that we have used in the new standardize, right? So standardize. And then you solve for your t. So this would be your t, right? Remember that var is negative t. So you are going to multiply this t by a negative number. So this would be your value of var. So when you are going to answer your question, so this would be the value of your var. Negative mu minus c sigma times the z score at that level. At the significant level alpha. So basically, you are able to just find this thing on your on your standardized normal tables. And then for discrete, my advice to you is to draw it like this. For discrete, you would have to either do the following. You can have your table of returns, right? Okay, let's say you have your return. Let's say you have your probabilities of return. You should put your returns in order. And then you're going to have your probabilities of returns, and then you're going to have your cumulative probabilities, right? Okay, let's say for example, you have -2, you have -1, you have 0, you have 5, you have 6, you have 7%, right? And again, let's say here the probability will be like 1%. Here the probability will be 4%. Then the probability of this one would be, let's say 10%. The probability of this one would be, let's say 20%. Again, let's add the other ones: 5, 10, 15. Again, let's just say that 35%, and then you're gonna have the remaining one. So just to be fast, I'll say 40, 50, 60, 70, 80, 90. Let's just say this would be like 20%. I hope they add up to 1. Let's say they all add up to 1, right? My advice to you is that you should have this table where you're going to have your cumulative probabilities, right? You're going to have like 0.01, 0.05, 0.15, 0.35, 3, 5. It's 0.70, and then you're going to have 1. So if they ask you, what is your VAR at a 5%, right? So you can see that at a 5%, you are going to look at these values here, below 5%. And you can see that you have two values, right? -2 and -1. And which one is the maximum? You're going to take the maximum one, which is going to be -1. So basically, your VAR is going to be -1 at a 5% significant level, right? Now, perhaps maybe I change the equation and say, what is VAR at a 10% significant level, right? You can see that the value of 10%, it is somewhere here. It falls under here. And then we want to find out the maximum value between -2, -1, and 0. And the maximum would be 0. So your VAR at a 10% significant level, you would have -0, right? So again, which is just going to be 0. So that would be VAR. I'm not sure if I'm making sense, but can let me say that they are asking you for VAR at a 2% significant level, right? I will use this color. Okay, let me see here. You can see that 2% falls within here, within this range here, right? So no, 2% fall within this range here. So you can see that 2% is more than 1%. So it would fall above this value here. So it means that your VAR at a 2% significant level would be negative. The maximum of these two, -2 or -1, would be -1. So your VAR would be 1. So this is what you need to do when you're trying to find your VAR. And I don't want to make this video any longer, so I'm going to stop here. Thank you.